Swayam Prabha. Digital India. Educated India.
Welcome to Module F, Lecture 2. In this lecture also we shall continue our discussion about car following theory. In Lecture 1, I mentioned to you what is really car following, the context of car following, the importance of the space headway, time headway, and then discussed about Pipes model and force model. Now, with this background, let us continue the discussion, and in this lecture we shall discuss about the car following models developed by General Motors. The car following theories developed by General Motors are much more extensive and of particular importance because of the accompanying comprehensive field experiments. Lot of field experiments were carried out. So, that is really the core strength of the General Motors model, and discovery of the mathematical bridge between microscopic and macroscopic traffic flow. You have seen that in earlier two models, what are the kind of assumptions that we made and what was the real basis for developing car following model. In General Motors theory, according to the theory proposed by General Motors, the response is a function of sensitivity and stimuli. What is the stimuli or stimulus? It is the relative speed between the lead and the following vehicle. You know that we always have two vehicles, one is the lead vehicle, another is the following vehicle. So, what is the relative speed between the lead and following vehicle? That is the stimulus. Sensitivity is actually a function of, as you will see, distance headway and speed of the following vehicles. And what is the response? Response is acceleration or deceleration of the following vehicle at time t plus delta t. So, whatever was the stimulus at t and what is the sensitivity, accordingly the response at time t plus delta t in terms of acceleration and deceleration is actually modeled as a part of the car following model. Now, although I mentioned about all these notations in my lecture 1, but still I have reproduced this slide once again to remind you that we are talking about two vehicles. One is a leading vehicle, another is a following vehicle. So, leading vehicle is denoted as n and the following vehicle n plus 1. Ln is the length of lead vehicle, Ln plus 1 length of following vehicle, and particularly what are the important thing in this context is xn is the position of lead vehicle, xn plus 1 is the position of following vehicle, x dot n speed of lead vehicle, x dot n plus 1 speed of the following vehicle, x double dot is the acceleration of the following vehicle, and delta t is the response. Now, the first General Motor model, we can write it like this. The sensitivity term, what we say stimulus and sensitivity. Stimulus is the relative speed. So, x dot n at time t minus x n plus 1, x dot n plus 1 t. So, at time t, what is the relative speed between the following lead vehicle and the following vehicle, multiplied by, in this case the sensitivity is taken as constant and then they tried actually to calibrate this value based on the field experimentation. Now, obviously, these stimuli can be positive, negative or 0, which would cause the response to be either acceleration or deceleration or a constant speed. For example, if x double dot n plus 1, rather if x dot n, the speed of vehicle n is greater than the speed of the following vehicle, that means the lead vehicle speed is higher than the speed of the following vehicle. Obviously, what would be the response? Response would be acceleration, because the gap is increasing. So, x dot n plus 1 at time t plus delta t would be actually positive, indicating that it would be acceleration. Similarly, if x dot n at time t is less than x dot n plus 1 at time t, that means the following vehicle is now becoming closer and closer to the lead vehicle. In that case, what is the logical response? Is deceleration. So, obviously, using this formula, what is shown here as equation 9.9, that will mean that x double dot n plus 1 at time t plus delta t will be negative, indicating that this will be deceleration. The response will be deceleration, because you are becoming closer to the lead vehicle. And when both speed of the lead and following vehicle is same, generally that means the distance is not changing. So, what is generally expected, that it will be neither acceleration nor deceleration, the same speed will be maintained. So, the acceleration deceleration will be 0. Very fundamental, very simple, and the basic formulation. That is what is the first generation model. Now, when this model was actually calibrated based on the field data, then this table shows that how the reaction time was calculated, how the reaction time was rather obtained, and what was the value of alpha, the sensitivity that was obtained. You can see here the reaction time varies from 1 second to 2.2 seconds with an average of 1.55. Similarly, the sensitivity average is 0.37, but minimum is 0.17, maximum is 0.74. What it indicates? The variation or the range is quite big, 0.17 to 0.74. It is quite a wide range. So, they started thinking that why this range is so high, and it came out that the sensitivity is also a function of the speed, a spacing of vehicle. What it came out, the sensitivity is also a function of the spacing between two vehicles. When two vehicles are closer and when these two vehicles are quite at a reasonable distance, the sensitivity is not the same. So, instead of one value, they suggested let us have two values alpha 1 and alpha 2. That is what is basically the second model. So, two values of sensitivity were taken or suggested. That is the second generation model. So, what was assumed, that when the vehicles are too close, obviously the sensitivity is high, because irrespective of whatever will be the role of relative speed that remains, but the sensitivity will be higher or highly sensitive value, high sensitivity value you will get when the vehicles are too close, and when the vehicles are far apart, a lower value of sensitivity is logical. So, they suggested a formulation like this. The only difference between the first generation model and the second generation model is, instead of having a constant value of alpha in the first generation model, here two values were suggested. One, when the vehicles are too close, a high sensitivity value, and when vehicles are far apart, a lower sensitivity value. Now, the difficulty is in selecting the values of alpha 1 and alpha 2, where to select alpha 1, where to select alpha 2 in discontinuous state. That led investigators to include that instead of saying higher or lower, why do not we include the space headway in the sensitivity term itself, because it may not be just two discrete value for two ranges, but it could be a term itself in the sensitivity value, or the sensitivity term itself may include space headway. That was done. That led to the development of third generation model. So, various values of sensitivity terms alpha were measured as an inverse function of the space headway, and data points closely followed a linear curve sloping upward to the right of the origin. That you can see here, that is what I have shown. So, this x axis is 1 by d, d is the distance or spacing. When the distance is higher, spacing is higher, then the 1 by d will be lower value, and your sensitivity value will be also lower. And when they are close enough, so x n t minus x n plus 1 t is a small value, obviously 1 by d is becoming higher. So, the sensitivity is also higher, closely following, two vehicles following closely. So, the sensitivity is obviously higher, and the sensitivity was expressed like this: alpha equal to alpha 0, a constant value, divided by x n t minus x n plus 1 t. So, what was earlier alpha in the first generation model? In second generation model, it was taken as alpha 1 and alpha 2, two values, and in the third generation, it was alpha 0 divided by the space headway, or the distance headway, or the space headway, right. And that is that way we are trying to explain how the whole sensitivity is changing. So, again here, as the spacing between two vehicles is reducing, sensitivity is going to be higher and higher. Okay. You can see here in this equation also, the value is reducing, x n t minus x n plus 1 t, lesser the value difference, then higher will be the value of alpha. Sensitivity term in third model is a function of constant alpha 0 and a space headway, as I explained. And obviously, with this, as I said, as vehicle comes closer, sensitivity term become larger. Dimension of alpha 0 constant in sensitivity term is maybe in meter per second, or the velocity, or it can be feet per second. So, the third model looks like this. What was constant alpha in first generation model? In second generation model, we used alpha 1 and alpha 2, two values. Now, the whole term is getting replaced by alpha 0 divided by x n t minus x n plus 1 t, this space headway or the distance headway, multiplied by relative speed as usual, x n x dot n at time t minus x dot n minus 1 n plus 1 at time t. So, the relative velocity of two vehicles at time t. Then the parameter values for third generation General Motors model, the values are shown here. In different tracks, this was tested, the data were collected and calibrated, and what the reaction time was found in a quite a close range, I should say 1.2 to 1.5 with a and 1.4. Here, two cases closer, 26.8 value of alpha 0, 29.8, but in GM test track first case it was 40.3. So, something could be explained, but still it looks like there is something which is still influencing alpha 0, it is not really a constant, that is the indication. What we considered as alpha, now partly it is explained the variation when we include this distance headway term, but then whatever still we are getting as alpha 0, it looks like it is still not a constant because it is varying. So, something else is actually again influencing the value of alpha 0. So, further thinking, further development. So, fourth model was a further development towards improving the sensitivity term by introducing speed of following vehicle. This is okay, that is the relative velocity. Sensitivity, obviously the distance between the lead vehicle and the following vehicle. If I am closer, my response sensitivity will be high. If I am at a distance, it is not so close, my sensitivity will be low. But it is not only the distance, but also the speed of the following vehicle. Let us consider the same distance between the lead vehicle and the following vehicle, but in one case following vehicle is travelling at a higher speed, and in another case the following vehicle is travelling or moving at a lower speed. Both cases the sensitivity cannot be same. So, another term was introduced. So, what they said? They introduced speed of the following vehicle, that also was introduced in the sensitivity term. So, the concept here is, as the speed of the traffic stream is increased or increases, the driver of the following vehicle is expected to be more sensitive to the relative velocity between the lead and following vehicle. For a given relative speed, for a given distance, higher the speed, higher will be the sensitivity. So, it remains in this form as a multiplier in the numerator. So, what is the fourth model? What was here in earlier case as alpha 0, the remaining thing, it is the relative velocity, it is the distance headway alpha 0 by x n t minus x by n plus 1 t. Now, alpha 0 gets replaced by alpha dash, another constant, multiplied by speed of the following vehicle x dot n plus 1 at time t plus delta t. Okay. So, now the sensitivity has got three parts alpha dash, a dimensionless constant, then x dot n plus 1 t plus delta t, speed of the following vehicle, and third x n t minus x n plus 1 t, the distance headway. 3 terms are there, right. So, the sensitivity depends on a constant, the speed of the following vehicle and the spacing between the lead vehicle and the following vehicle. Now, fifth generation model was actually a continued effort to improve and generalize the sensitivity term. This was implemented by modifying the fourth generation model, but trying to make it more generalized by introducing two components M and L. Then the equation looks like the response is not alpha only, but alpha Lm, it depends on L, it depends on M. The speed of the following vehicle to the power m, what we considered earlier case in fourth generation model, m equal to 1. So, now it make it a generalized term to the power m divided by x n t minus x n plus 1 t to the power L. What was considered in the fourth generation model? L as 1 into the relative speed, as it was there in first generation model, second generation model, third generation model and fourth generation model. Same term continued also in the fifth generation model. So, this was the final car following model which was developed, and it was eventually found or realized that all previous general motor car following models were actually special cases of this generalized fifth generation model. What is L? L is the distance headway exponents, that is where, because this is the distance headway to the power L. So, it is the distance headway exponent, and what is m? It is the speed exponent, because it is x dot n plus 1 at time t plus delta t. Now, if you see, if we try to plot this speed exponent m and distance headway exponent L, and then try to see what values make what model out of all this first generation, second generation, third generation, fourth generation, and fifth is obviously generalized one. Now, if you see, when the L is 0 and also the m is 0, m is here, m is 0, L is 0, then it is actually first and second generation model, right. That is what you found, that is what is our first and second generation model, because if you put in the fifth generation model, I think in this slide also I have written, this is the generalized fifth generation model, m is 0 means the whole term becomes 1, L is 0, again the whole term becomes 1, then what remains is only alpha, a constant. That was nothing but the first generation model, car following model as developed by General Motors. Then second is also that L is 0, m is 0, but we use two values of alpha rather than one constant value, here we use two values. Okay. So, that is again L equal to 0, m equal to 0. Now, if you see the third generation model, then actually what is taken, m is taken as 0 and L is taken as 1, that is the case. So, again in the fifth generation model, if you consider m is 0, then this term in the denominator, the speed of the following vehicle will not be there, it will be 1 and L is 1. So, a constant divided by the relative speed, relative spacing or the actually the space headway, relative position of two vehicles. So, which is the distance headway or the space headway. So, that gives you the third generation model. Fourth generation model you get when you take both L as well as M both as 1. M is 1, L is also 1. Then a constant multiplied by the speed of the following vehicle divided by the spacing between the lead and the following vehicle. So, this L is 1, M is 1, that is nothing but the fourth generation model. So, fifth generation model is actually a generalized model and all the first, second, third and fourth generation model became the special cases of the fifth generation model, depending on what value of speed exponent you are taking and what value of distance headway exponent you are taking. So, altogether what we discussed in the present class is about the General Motors theory. Response depends on two things. Going to the first slide, response depends on stimulus and the sensitivity. Stimulus is relative speed. What could be the sensitivity? Finally, the sensitivity depends on the distance headway and also the speed of the following vehicle, and depending on how or what value you are considering for the speed exponent m and the distance exponent L, you get all these models. First generation sometimes with certain assumption of 0 0, L 0, M 0 you get first generation, L 0, M 0 you get again second generation, L 1 M 0 you get third generation, L 1 M 1 you get fourth generation, and any generalized value L and M, any other value, you get actually the generalized fifth generation model. So, with this I close this lecture, and in the next lecture we shall take a numerical example and show you the calculations based on the General Motors model. Thank you so much.